everybody, very good afternoon everyone. So this is myself Dr. Saranya. I am talking to you about a very important topic. So many questions will be coming up from this topic. Yes, so in both your DBT examination as well as your CSIR NET, and you definitely know about the track of record that we are having. So many have cracked the examination. So please wait for more important courses. So currently I am conducting two courses live. One, it is the molecular biology master class. This will be conducted at 9:30 AM every day, and just this jumbo DVD practice course, this is by 12 PM every day. So these courses are seriously meant to make you out a better performer in the examination. Right, good afternoon everybody in the class. So happy to see you all back. Yes, Khan, Debshish, Ramprabha, Guharia, fantastic. Right, so the first one that we are going to see today regarding your chromatography, gel filtration chromatography. So what is this gel filtration chromatography meant for? This gel filtration, it is going to separate based upon the size, based upon the conformation. Okay, so usually what sort of questions do come from this? For example, I am having a, yes Garia, I am having a big protein, I am having a smaller protein, or I am having a multimer and a monomer. Okay, and then I am having your dimer, something like that. So if it is going to be a subunit, monomer it is very small, multimer and dimer it is going to be pretty big. So based upon the size you can separate them, right? So and like large, medium and small sized proteins can be separated by using this technique. Apart from separating them based upon the size, conformation. For example, if at all I am having a plasmid and I am having a linear molecule, I can definitely separate them by using this chromatography, gel filtration or size exclusion chromatography. So let us see what is going to be the principle behind this separation. Yes, so the basic principle, it is going to be based upon the size and conformation. Okay, so number one is size, number two is conformation. These are the two main things by which you can separate your molecules of interest. So now what I am doing is that this is going to be my Cephadx column. Okay, and you have to remember that it is an isocratic gradient. Have you heard this term, isocratic gradient? What do you mean by an isocratic gradient? Do they change in the pH? No. Okay, so there is no change in pH. It is uniform. Okay, the pH is going to be uniform. That is why you call them to be the isocratic column. Okay, so here you don't change any pH. Okay, so this gradient is maintained to be a constant. So it is not at all taking up any much thing with this gradient. Right. So now you are filling them with your protein sample. So your protein sample is now mixed. So now what happens, if at all my protein is very small in size, when compared to my Cephadx bead, my protein will move inside and sit inside my Cephadx. This is nothing but it is a Cephadx bead. Okay, so if at all I am using my Cephadx bead, my protein is very small. It is like a filter, no? So all my protein will go and sit inside this filter. Okay, right, it is very small so it can enter. But imagine what will happen to my large protein. Can it enter inside the filter? Yes. Can it enter inside the filter if at all I am having a very large protein? Can it go inside the filter? Definitely not, isn't it? So it will never go inside. Why? Because, yes, why? Because this is, this is going to be, Alright, so this is going to be this is going to be added whenever this is what to say. So whenever it is very small only it will go inside. If it is going to be quite big, it cannot enter inside your Cephadex column. Understood? So this can never enter inside the Cephadex column. So that is why this is not going inside. The moment it is not going to go inside, what will happen? Yes, everybody. Yes, Kirti. It will come out. So that is why my large protein, it is eluted first. So which one is eluted first? My large protein will be eluted first. And what is the second one? The medium. Medium is sticking to the sides, right? So that will be eluted second, and my small proteins will be eluted third. Everybody in the class, did you get it? We'll make one more quick recap about this gel filtration chromatography. This gel filtration chromatography, this is meant for separating the proteins based on size as well as conformation. Okay, so what is going to be the interpretation? What is going to be the interpretation? My small sized protein, it will go inside my bead. Okay, medium size, it will stick to the bead. Okay, large, it will be not binding, so it is eluted first. Okay, so this is how the result is. First large will come out, second is medium, third is small. So don't trick it with your SDS page. In your SDS page, always what happens? Large will be stuck at the top, medium in the mid, and small at the bottom. Correct? Here it is coming in this order. First it will be large, then medium, then small. Small will come at the last. It will elute at the last. This will elute at the first. Understood? So don't confuse it with your normal gel electrophoresis. It is opposite to that. Understandable? So let us make a move towards the next next important thing. Yes? Okay, here you can see something called as absorbance. So you can see that 1 and 3, they are showing a peak, right? 2 is showing down. So what does it mean? It is showing high. Does it mean that this is going to be a large protein? No, this is the large protein, this is the small one. This is only telling the order of elution. So large, medium, and then small. What is this telling? This is telling about the intensity or how much proportion it is present. So this tells that number 1, it is containing more proportion of my component. Understood? So that is what this fellow is telling on. Okay, so let us take one more. So this example I am illustrating it based upon this urea. So what will urea do to our protein? What will this urea do to our protein? Urea will make the unfolding. Okay, right. So see here, this is the native protein. It is completely folded. Okay, right. Then I put it into 2M urea, little bit unfolded. 4M urea, still more. 8M urea, completely unfolded. Got the point? 8M urea, it is completely unfolded. Now, yes, it is denatured completely. Now, you honestly tell me, yes, which will come under this point? Which will elute first? Which will elute first? Native protein, option A, 2M urea, 4M urea, 8M urea. Which will elute first? Which will elute first? Think over and tell me. Which is very large. See, native is highly folded. If it is going to be folded, it will be large or small? If it is highly folded, it should be small. No. Got the logic now? Yes? If it is 8M, it is unfolded. So unfolded is only going to be the large. The large one will only elute first. So this is going to be your 8M urea denatured protein. Understood the logic now? Everybody in the class, if you understand this, then only it will be easy for your interpretation. Okay, right. So, so is this all clear? Done? Everybody in the class, did you get it? Fantastic. Yes. So this is going to be the order. So last one will be your native protein. Got it? Fantastic. So now we are going to see the second chromatography. This is another important chromatography. It is called as your ion exchange chromatography. Yes, everyone. Come on, guys. So seriously, this ion exchange chromatography, it is a very, very important fellow. Yes. So let us see that in detail. Yeah. So, but separation is based on conformation also. Correct. Yes, Ramprabha. Conformation also, you see, this is the folded conformation. In folded, it is going to become small. No. That is the logic behind this. Because if you see the molecular weight, not much difference is going to be there. Got it now? So this molecular weight almost, maybe a minor difference will be there. You cannot separate them based on molecular weight difference. This is separated only based on conformation. The same thing I told you, if it is going to be a plasmid, it will be eluted last. If it is going to be your linear DNA, that will be eluted first. Got it? Got the difference of how this works? Yes? If it is going to be a linear DNA, it will be eluted immediately. But if it is going to be a plasmid, your plasmid is totally crushed, isn't it? So it cannot come out, it will go inside. So you cannot compare it with molecular weight, but based on conformation, your native protein, it is going to come like this, and your folded ones, natives, the folded, that will be lost, and your unfolded protein, it will be eluted first because it is pretty large. Understood? That is why I put you this question. Right. Good. So now we are making a move towards the second important chromatography. It is what is called as your ion exchange chromatography. Okay, right. So as far as this ion exchange chromatography is considered, so this principle, the principle behind this method, it is going to include number 1, the electrostatic interaction. Right. Number 2, it is about the resins. Okay. So this is a very, very important point that you have to understand. See here, you have a cationic exchanger. Number 2, it is an anionic exchanger. Okay, so there are two. One, it is going to be the cationic exchanger, and the other one, it is going to be the anionic exchanger. Cationic exchanger means what should be the charge of the bead. First you tell me what is an anion. Anion means negative charge. Does everybody agree? Anion is negative charge. Cation is positive charge. Okay, right. So anion, it is going to be negatively charged, and cation, it is going to be positively charged. Now this resin is going to exchange my cation. So what should be the charge? The resin will be negatively charged, okay, such that it can bind the positive charges. Understood? Yes? This point is very, very important. So, if at all I am saying that it is a cationic exchanger, I am telling that it is an anionic resin. Okay, so the cationic exchanger is nothing but an anionic resin that is capable of binding all my cations. Got it? Right. Next, what is an anionic exchanger? Anionic exchanger means it is going to be a resin that is positively charged. Okay, so it is positively charged, so it attracts all my anion. This point is clear to everybody in the class now? Yes? So if I say that it is an anionic exchanger, it is nothing but it is a cationic resin. This point everybody should be clear with. Okay, so is this all clear to everybody in the class? No doubts on this? Shall we just make up a move towards the next important point? Yes, two things are there in this thing. One, it is going to be this, and other one I'll tell you. So now you see, yes, you have to find the charge of your protein. Okay, right. So finding the charge of the protein is very, very important. If at all the pH is going to be less than Pi. Okay, so the pH is going to be your environment. This is going to be you. If you are less than your friend, how you will feel? You will feel positive or negative? You are getting something less than your friend. Immediately you will have all the negative feeling. That's all. If pH is less than Pi, it is negative. If at all the pH is, if at all you are, if this pH is less, it is, you are better than your friend, you feel positive. Yes, and your friend is going to be better than you, you will feel negative. Yes, I wrote in the opposite manner. Right, but anyway, so if you are better, you are great, you feel positive. You are less, you feel negative. That's all. When your Pi is equal to pH, then what is the net charge? What will be the net charge when the Pi and pH are equal? It is going to be zero charge. Yes, absolutely, Ramprabha. So it is going to be the zero charge. Okay, right. So when the pH is less or your Pi is high, you feel positive. When the Pi is it is going to be less, you feel negative. And if they are equal, it is zero. Okay, so based on this concept only, your ion exchange chromatography works. So the resin, it is, for example, if it is going to be a cationic exchanger. Cationic exchanger means it is an anionic resin. Okay, cationic exchanger means it is anionic resin. So the beads, okay, it is negative. Okay, so positive charge protein will bind to these beads. Right. So who will be eluted first? In this cationic exchanger, you have two things. Okay, so one will be eluted first and the second will be eluted late. I will tell you a simple clue. Whoever is in the title should come second. So who is in the title now? Cation. So who should come second? Cation. So who will come first? Anion. Got the clue? I will tell you one more time regarding the interpretation. Yes. See here, if at all it is going to be a cationic exchanger. Okay, so I will tell you always the VIP will come late, isn't it? So the speaker will be the latest one. Correct, it will be the last one. The program will end after the speaker speaks. So who is in the title now? Title is cation. So a cationic exchanger, who will come at the last? It is the cation. Who will come at the first? Anion. The same in case of your anionic exchanger. Now who will come at the last? So now who will come at the last in an anionic exchanger? In the title it is an anion. So anion will come late. The cation will come first. Now you understood the logic, which will come first and which will come last? Yes, exactly. Okay, good. So this is about your exchanger. And the third one, it is going to be the affinity chromatography. In affinity chromatography, it is all about this binding. Okay, so there are many forces that helps in the binding. Number one, it is going to be the salt bridge. Okay, salt bridge is an important one. Followed by your hydrogen bonding, right? Followed by this van der Waals interaction, okay, and then pi interaction. So these four forces, they make the affinity chromatography. Got it? So what is the principle? It is based on salt bridge, hydrogen bond, van der Waals, pi. It is all the bonding that make up them. So there are few important things you have to remember. Yes, if it is going to be avidin, biotin binds. Avidin and biotin, they bind up. Poly A, poly U. Okay, lysine, RRNA. Okay, lysine, RRNA. Lectin, glycoprotein. Okay, lectin, glycoprotein. So these things are very, very important. So in your exam also many times this has come. Hexahistidine, nickel. Hexahistidine, nickel, very important combo. Glutathione S transferase, glutathione. Flag, anti-flag antibodies. Avidin, biotin, right? Yeah, streptavidin binding protein, streptavidin. That is nothing but biotin. Maltose binding protein, amylose. So like this, everything is important. Okay, so we will make a move towards the fourth type of chromatography of the day. Yes. So what is going to be the fourth type of chromatography for the day? It is going to be the hydrophobic chromatography. In hydrophobic chromatography, it is about a non-polar. Okay, polar means hydrophilic. Your hydrophobic means it is going to be the non-polar fellow. Okay, so non-polar is what is called as hydrophobic. Understood? Right. So here what happens in hydrophobic, you put the high salt, yes, the protein is going to bind to this matrix. You put the lower salt, it is eluted. So you are going to decrease the salt. Usually you will keep on increasing the salt gradient. Here you decrease the salt gradient. So that is a very important point that is happening here. It is all reverse. So that is why this is called as reverse phase. Okay. So here can you guess who will be in the second? Who is in the title? Hydrophobic. So hydrophobic will elute second. Okay. It is same for here also. If it is going to be hydrophobic, it will elute the second. Okay. Right. So shall we just try a few questions? Everybody in the class, depending upon the interpretation that we have studied, shall we just try a few questions? Yes or no? Come on, everybody in the class. Cheer up for your preparation. Yes? All right. The samples of antibodies, they were electrophoresed under denaturing and reducing conditions on this acrylamide gel, followed by staining with this Kumasi blue dye. Samples 1, 2, 3 showed 2, 3 and 4 bands respectively. Which one of the following can be made from these observations? Sample 1, it is IgG that has 2 sample 1 is IgG, 2 is IgA, 3 is IgM, or which could be the correct answer? See, 1 is 2, 3 and 4 bands. Come on everyone. Who will get 4 bands? Make it fast, make it fast. Everybody is here or what? Type the answers in the chat box. So the correct answer is going to be answer C. Okay. So answer C says that your sample 1 is IgG and sample 2 it is going to be IgM. Yes, and sample 4 it is going to be your IgA. Surprised? See this, if at all your IgG is there, no. So here this disulfide bond will hold your light chain and heavy chain. So you are getting only 2 bands. 1 band it is due to your heavy chain, okay, and 1 band it is due to your light chain. That's all. Gone. So for IgG 2 bands. Yes? Correct? No, first is showing 2 bands. So IgG is the right answer. Got it? Fine. So in IgM it is a pentamer. That I agree. But what are the subunits? It is going to be your light chain, heavy chain, J chain. Only 3. Light chain, heavy chain and J chain. So 3. So it is 3. Okay. So for A only it is 4. Because apart from your light chain, heavy chain, this also contains called as the J chain, isn't it? It contains your light chain, heavy chain, J chain. Apart from that, IgA is secretory, no, it contains the secretory components. So it is going to have the 4. Got the answer? Yes. So IgG, it is going to contain only 2 chains, light and the heavy. And IgM, it has 3 chains. Okay, so light, heavy and J. And then IgA, it has light, heavy, J and then secretion. It is a secretory antibody, no? It gets secreted. So that is why answer C is going to be the correct answer. Got it? Okay, so next question is pretty simple. Several fusion proteins were developed to purify a E. coli. So this list is telling us something. Maltose binding protein, where it will bind? Be quick. Come on everyone, answer it, answer it. Maltose binding protein. Amylose, no. Right, streptavidin. Just now we saw biotin. Very good. S. Srijan De, Ramprabha, good. Glutathione S transferase. Glutathione. Flag tag, special monoclonal antibody. Fantastic. Histidine tag is nickel. Okay, so this is how every year questions are being asked. Okay, so shall we do few more questions? Everybody is ready? Alpha bungarotoxin binds to acetylcholine receptor, which is highly specific and it prevents the ion channel opening. This interaction can be exploited using which of the following method? It binds to acetylcholine receptor. If it is binding to, which should be answer? Fantastic. If it is binding to, absolutely affinity should be the answer. A thin layer chromatography experiment using a silica gel plate, the compound showed a migration of 12.5 centimeter. Okay, so this is the solute and the solvent, it is showing a migration of 18 centimeter. So now what is the RF value? Done or what? Fast, fast. Done or what? Very good. So see here, now what is happening is that the compound has migrated 12.5 centimeter. So this is the solute and the solvent is 18. Okay, so 12.5 divided by 18 is going to be the RF value. So what is that? It is coming around 0.69. That's all is the answer. Got it? Everybody in the class? That's all. Fantastic. So a researcher investigated a set of conditions for the protein for which your isoelectric point 6.5. This can bind your calcium. So now pH 6.4, that means it is near isoelectric point. Second one, it is 10% glycerol. Third one, 10 millimolar of calcium chloride is soluble. Fourth one, 40% ammonium sulfate precipitation. So the percentage of protein in the supernatant it is given. So now you are going to find it out. So in the supernatant, if it is more, it is going to be solubilized or a precipitate. supernatant, if something is more, it is not solubilized. Done or what? Can you map it? Ammonium sulfate, glycerol, pH. We'll go option by option. Okay. Can this first one, can it be my pH at 6.4? Can I keep it? Will this come like this way? No, no. Why? Yes, Ram. So why it is no? Because it will precipitate. If it precipitates in solution, in supernatant, nothing will be there. Got the logic? Okay. Second one, it is going to be 10% glycerol. So it is going to be 10% glycerol. Okay. Right. For example, if you check out, can it work out? Glycerol is meant for dissolving. Dissolve means supernatant wise it should be high. So can it be a glycerol? No, it cannot be a glycerol and calcium. So it should be either your PI or your ammonium sulfate. Okay, so this can be glycerol. This can be glycerol or ammonium sulfate. Got it? But these two, it is definitely not going to be that. So this is going to be your precipitation. Alright, and this is going to be your ammonium sulfate exchange between these two. Understood? So shall we take the next important question? This is also another important one regarding the interpretation. Shall we do it? Everybody is ready for it? So here, what should be A? Cation or anion? What should be the A? I gave you a clue also. Whoever is in the title should come at the last. Think and answer. Who is in the title? Who is in the title, ma? Cationic Exchanger. So this Cationic Exchanger will come late. So first is going to be anion. Very good. Yes, Nehal. Yes, Ramprabha. It is anion. Size exclusion. What should be first? Large or small? Okay. Is it correct? Size exclusion. Large is first. Reverse phase. That means you are hydrophobic. So this is going to be hydrophilic. This is going to be hydrophobic. Got the logic? Yes? Okay, accordingly you can answer this question, not a big deal here on. Okay. So, ion exchange chromatography, what is the principle? I told you, in ion exchange you will increase the salt. In hydrophobic you will decrease the polarity. Gel filtration, it is isocratic solvent. Chromatofocusing is where you use the ampholytes. Got it? So I hope that all the things are pretty clear to you. Yes? Okay, fine everybody. So I hope that this is all clear. So we'll catch up in one more session. So please revise, please keep practicing, please keep following. All the very best. So batches are going on all a full swing. So please enroll yourself at the earliest such that you will get the maximum benefit out of it. So you can use my code Saranya Live if you seriously like the way of my teaching. All the very best everybody.